We started today's topic is graphs and graphing utilities. Graphs and graphing utilities. What do we use to graph? Okay, what kind of tools we're going to use to graph? Now we do a quick review. I believe that was something that you learned a long time ago. It's called a number line. Okay, or a number line. Number line is a straight line, if you remember. And usually you put an arrow here at the right. That means it goes greater and greater. And some textbook also put an arrow on the left side. It doesn't really matter. So the first thing is you should have a straight line. And then after that, you're going to have a point on this line, and we call that a 0, which is the origin. That's where this point here. And then to the right, here is going to be 1, here is going to be 2, and of course for the same distance, here is going to be 3 and 4 and 5, and this line can continue. It will go to the right to, and also to the left, if you learn the same unit, okay, the same unit, and here's -1, and here's a -2, and so on. So if I give you this straight line, then you can show any point I ask you on this number line. For example, can you find, I call this x, I just use x as the letter to show the number. Can you tell me where is 2.6? Can you find it? Well, here's a 2, here's a 3. 2.6 is somewhere between 2 and 3, but right in the middle is 2.5. So 2.6 is a little bit to the right. So this point, okay, is 2.6. All right. And some questions they ask you, can you find 2.6? You say, here it is. No, here it is. Okay. That what they're asking you is to find the point on the number line, or also it's called, can you plot the point 2.6 on this number line? Now this is a one-dimensional space, isn't it? It's one-dimensional because it's all just the straight line from left, from right, and then that's the one way. So that's a one-dimensional world. And what about the two-dimensional world? Then you're going to have something like this, another line. Then you have this plane. Okay, so that's a two-dimensional space. Line is a one-dimensional space, and then world, and then this plane is a two-dimensional plane. For two-dimensional plane, we're going to have, usually, okay, we're going to use this is an x. We call that x-axis. And you always put a 0, 1 because it shows the unit, the length of the unit, and it shows where the origin. And the other one, another line perpendicular to this, so that form a 90 degree here. And this is y, and it's usually about the same length on the y-axis. So sometimes they're different, but very few. Okay, in this case, it's the same. Now we have this. And that is x, that is y. If I give you a paired number, for example, if I give you the number 1, 2, all right. Now this is called coordinate of a point. Coordinates of a point. This 1 is called an x coordinate, and the 2 is called a y coordinate. How do we find this point? That means x is 1, y is 2. Remember, this is x is 1 is here, and y is 2, which is here. And then can you find the point? Yes. So it's going to be here. That's my point, 1, 2. Now, you see that a paired number and a point on this plane, they have like a 1-to-1 relationship. Make sense? So if I ask you 1, 2, you just point it here. What about this point? This point. It's just 0, 0, isn't it? All right, now here I'm going to introduce you some concepts. This, we know this is the x-axis. So x-axis, okay, it's a horizontal line. and the vertical one is called y-axis. All right, and 0, 0 is called origin. That's where both x and y coordinates are 0. So the whole thing is called coordinated planes. All right, now these two lines or these two axes cut this space into 4 regions. Did you see that? So here's one region, and here's another region, and here's another one, and here's the other one. So we call that quadrant. Okay, so this is called quadrant 1. And of course, this is 2, this is 3, and this is 4. Okay, so that's a first quadrant, second quadrant, third quadrant, and a fourth quadrant. So you should remember this. It's always the same, okay? In any book, it's the same. All right, now, for any point on the first quadrant, their x-coordinate is where, if you drop that point to the x-axis, see like this one, 1, 2. If you drop it, okay? If you drop it to the x-axis, that's 1, okay? If you look at horizontally, if you look at where it should reflect on the y-axis, which is 2. So for any point on this first quadrant, the paired number has to be positive, positive. Make sense? Because all the x-axis are positive, all the y-axis are positive. So therefore, any point on quadrant 1 has a positive, positive coordinates. What about this one? This one, the quadrant 2. Okay, for any point here, their x-axis got to be negative, and their y-axis, their y-coordinate, their x-coordinate is negative, their y-coordinate is positive. So we have a negative, positive. Okay, and then this one, this guy, any point here, the reflection on the x-axis is negative, on the y-axis is also negative. So this is negative and negative. Okay, very similar. Here is a positive, and here is a negative. So just by looking at the signs of this paired number, then you can see which quadrant that point should be, isn't it? Okay, if you're confused, you can pause here and then you go back and review this part again. All right, now next one, we're going to do a quick exercise. All right, I'm going to ask you to show me 5 points. A, -3, 5. B, 4, -2. C, 5, 0. D, -5, -3. E, 0, 4. And F, 0, 0. So can you tell me where are those 5 points? Okay, and I have I bought this little board, but for some reason it shows the reflections. You can see the lights here, so I might tilt this a little bit, and then I don't know. It's going to be. Let me do that. All right. So make it a little easier. All right. Now for this one, here's the origin. Yeah. And then this is 1, this is 2, 3, okay? And I think this is my x-axis, and this is my y-axis, and here is 1, and here is 0. So that's, oh, it's not clear enough, huh? Okay, let me change to another color. Let me change it to red. Maybe that will work. All right, now let's find the first point, -3, 5. That means when x is -3, -1, -2, -3, and 5, +5, that means I have to go up. 1, 2, 3, 4, 5. See here? That's A. Okay, so -3, 5. And the next 4, positive, negative, positive, negative in the quadrant. So 1, 2, 3, 4, and the -2. You see what I'm doing? 1, 2, 3, 4, and then down by 2. So that's my point B. All right. And then the next point is C. C is a 5, 0. So x-axis is x coordinate 1, 2, 3, 4, 5. And the y coordinate is 0. So that means it's not going up or down, just stay on my x-axis. So that is a C. Okay, I want you to see that for any point on this x-axis, all the point on this x-axis, their y coordinate is always 0. Similarly, for all the point on the y-axis, their x coordinate should be 0. Now look at the next one, -5, -3. -5, you're with me? 1, 2, 3, 4, 5. -3, 1, 2, 3. So that's my point D. Okay, and then the next one is, sorry, 0, 4. 0, okay, when x coordinate is 0, I know it's going to be a point on the y-axis. 4, I go up by 4. 1, 2, 3, 4. So here is my point E. All right, and then the last one, F point is 0, 0. And that's very easy. It's just right here. Okay, so that's how you locate or plot those 5 points, A, B, C, D, E. All right, so next part after we do this, we're gonna continue. And then we already know how to plot a point. That's not a problem. Okay, now next, how do you graph? How do you graph a relationship between x and y in an equation? For example, how can you graph y equals 2x plus 1? Can you do that? How do you graph y equals 2x plus 1? What it means, what does this mean? This means I ask you to show me the graph or the picture of whatever. It might be a line, might be a curve, might be something. For any point on that line or any point on that curve, their x and y coordinates should satisfy this equation, y equals 2x plus 1. How should we do that? I need to get points, right? Okay, so let's try a little bit. Let's pick some x and find some y. So I get like an ordered pair, right? When I graph that. So usually when I see this, there's really nothing special value. So I choose this. I choose x equals 0, -1, -2, and 1 and 2. So that means I choose 5x value. And how to get the corresponding y value? I just plug it into this equation. When x equals -2, -2 times 2 is -4. -4 plus 1 is -3. When x equals -1, 2 times -1 is -2. -2 plus 1 is -1. All right, and the 0. Plug in x equals 0, or substitute x by 0, which is 2 times 0, which is 0, plus 1, so that's 1. And x equals 1, 2 times 1 is 2, plus that is 3. And then when x equals 2, 2 by 2 is 4, 4 plus 1 is 5. All right, so I picked a 5x value, and then I get a 5 corresponding y value. What does that mean? That means I get a -5 and -3. This paired number is a point, isn't it? And then I also get a -1, -1. Of course, you don't have to write it out because it's okay if you can read that from the table. But I write it out because I really want to show you what do I get. Okay. All right, now can you find these 5 points? I think I'm pretty good drawing this, so I just stop using my board. It's very confusing. So here's a 0, here's a 1, and a 2, and a 3, and a -1, -2. Okay, 1, 2, 3, 4, 5. 1, 2, 5. Okay, I saw when students doing this graph, 3, 4, that's -5. All right, you can just try to make sure that each number, between each number of the space is the same. Spread them out evenly. Because I do see some students, they go like 0, 1, 2, 3, and 5. They do things like that. That's not right, okay? Try your best. -2, -3. Let's see. -2, -3, which is here. Okay, I make this really big. -1, -1, which is here. Okay, 0, 1. You see what I'm doing? 1, 3, 2, 5. Did you notice something? You notice that all the 5 points given, they stayed on a straight line. So if you have this, you can connect that. You get this line. I ask you to graph this function or this equation. Sorry, I ask you to graph this equation. And what I'm asking you to is to pretty much find all the points that satisfy this equation for all the x, y. Of course, x can be anything, so I cannot identify, or I cannot pick all x value. So I just pick some value. I want to see the pattern, and then I draw that. After I draw the line, I said this is the graph of y equals 2x plus 1 for any point on this line. See 3 here? If you see where is that? This point, that's a 3, 7. Okay, and if you put 3 here, 2 times 3, which is 6 plus 1, that's a 7. So even I didn't list out all the possible x values, which is impossible, and I just pick some number of x and plugging that to get the y, then I get several paired numbers, and then I plot them, I see the pattern, I can just draw the graph. And any point on this line, this is important concept, any point on this straight line, their x, y coordinate will satisfy this equation. So that's how you graph an equation. Let's graph another one. Okay. We're going to graph this one. Y equals 4 minus x squared. Okay, this is not that obvious, huh? But anyway, we do very similar thing. We pick some x and figure out the y. Okay, if you like, you can also write here y equals 4 minus x squared. All right, so x, again, I pick this 2. Okay, if you like, you can put 3. Okay, or you can put more, it doesn't matter. Now x equals -2, you plug this here, -2 squared, which is 4 minus 4, which is 0. Of course, what you do is 4 minus -2 squared. I leave this here as a little note to show you how do you get the 0, okay? And when x equals -1, you should do 4 minus -1 square, which is positive 1 here. 4 minus 1, that's a 3. Okay? And when x equals 0, I stop doing that. When x equals 0, you put in 0 here. 4 minus 0, which is a 4. And a 1, 4 minus 1 square, which is 4 minus 1, which is 3. For 2, x equals 2. 2 squared is 4. 4 minus 4 is 0. When x equals 3, this is optional, okay? When x equals 3, 4 minus 3 squared, which is 9. 4 minus 9 is -5. It starts getting interesting. All right, I'm going to graph. Okay, you may say, well, I don't know how long should I mark those numbers. It doesn't matter. 1, 2, 3. 1, 2, 3. So if you like, you can buy those grade paper. Looks like the board I just got, it was on paper, and that might help sometimes to help you to graph a little bit. Okay, so this is -1, and here's a 1, a little higher, and a 2, and a 3, and a 4, and a 5, and here's -1, -2, -3, -4, and here's -5. All right, so let's plot those 6 points, negative 2, 0, negative 2, 0, which is here, okay, negative 1, 3, negative 1, 1, 2, 3, which is here, okay, 0, 4, here's a 0, 4, 1, 3, 2, 0, and 3, negative 5. And I can imagine that when it's negative 3, it's also negative 5. But it's okay because I didn't calculate that. What do you see? It's not a straight line. See? It's not a straight line. It should be a curve. So it's going to look like this, right? Go up and down. I'll tell you a little trick when you graph this up and down curve. Do this part first to make it a little flat so you don't have like a sharp turn. Okay, so you make it a little flat and then you try to draw a curve as smooth as possible. As smooth as I do my best, of course, and I'm still okay. Not bad. So this graph is y equals 4 minus x squared. For any point on this curve, their xy coordinates will satisfy this equation. Okay, do you want to see what happened when x equals 1.5? Here. So when x equals 1.5, y should be 4 minus 1.5 squared. That would be 4 minus 2.25 and should be 1.75. So do you have 1.5 and a 1.75 this point? 1.5 and a 1.75. See, it's right here. Okay, is that right? So any point on this graph would satisfy this equation, y equals 4 minus x. That's how you graph it. Now you get the idea how to graph a equation, right? So this is called a quadratic equation because it has a square involved. And the first one we graphed is called a linear equation because it only has the x term. It doesn't have the square, it doesn't have the square root, it doesn't have like x in the denominator, it's just a simple x. And here we have a square, so that's a quadratic. All right, so try one more. I think you already get the idea how to graph a function. The one more will be y equals x plus 1 absolute value. This is tricky. Okay, quick review. What is the absolute value? Absolute value of a number which would only take the number itself. We ignore the sign, or or the other way is we're gonna change all the sign to be positive. For example, I'll give you a quick example here. Okay, this is the review part. Okay, 5. Absolute value of 5 is 5. Absolute value of negative 5 is also 5. What is that? That means if you plot this point on the number line, this 5 means the distance between that point to your origin. If you plot a negative 5 on the number line, which should be like a 5 unit to the left of the origin, and what's the distance between that point and 0? Is also 5. So we only talk about a positive value. So what about a negative 200? Absolute value, that is just 200. I just made this up. And 7 absolute value should be 7. No, 0. Absolute value of 0 should be just 0. Okay, so that's a quick review of this absolute value. Okay, review. Finished. And this one, y equals x plus 1, absolute value. We put 2 vertical bars around it. It shows the absolute value. And this is called the absolute value equation. All right, similar idea. Pick some x, find the y, which you should just do x plus 1, then take absolute value. All right, so again, we do 0, negative 1, negative 2. If you feel like unsafe, you can do negative 3. It doesn't matter. So here, 1, 2. Usually this is good enough, okay? When x equals negative 2, we have to do the inside the absolute value sign first, right? We have to do this operation first. So negative 2 plus 1, which is negative 1, absolute value, 1. When x equals -1, -1 plus 1 is 0, absolute value of 0 is 0. When x equals 0, 0 plus 1 is 1, absolute value 1. X equals 1, 1 plus 1, 2. 2 plus 1, 3. Okay, you ready? It's my habit. I don't put the arrow on the left side. I just do that on the right side. It means it goes greater. That's my habit. You can if your teacher in middle school or in your school ask you to do arrow on here and here, it's totally up to you. Okay, so -2, 1, -2, 1. I got this point. -1, 0, -1, 0, 0, 1, 1, 2, 2, 3. You see the pattern? If you like to have a -3, that's okay. When x equals -3, -3 plus 1 is -2, so the absolute value is 2, so it should be here. Okay, what do you get? You get something looks like this. See, they are on a straight line, and here is also a straight line. Yeah, that is. So y equals the absolute value of x plus 1. After you take the absolute value, it has to be either 0 or positive. So that makes sense, right? See, all the y coordinates are either 0 or positive. So that's right. So that is y equals x plus 1 absolute value. So that's how you graph this. All right. Now we learned how to plot a point on a number line, and we learned how to graph a function on the xy coordinate plane. And then the next one, we have to learn some concept. The concept, I think that's a third task today, right? We're going to learn what is called x-intercepts, x-intercept, and y-intercept. X-intercept is, remember this, that's an x value when y equals 0, or where the graph touch or cross x-axis. Of course, y-intercept will be the y value when x equals 0. Remember, x equals 0, that's a y-axis. So we can say, or where the graph could touch, okay, or could cross y-axis. All right, now let's go back to this function. Remember this function here? All right, so what is the x-intercept? X-intercept is where the graph will, see, this one is going to cross this x-axis when y equals 0. Where is that? It's a -0.5. That's your x-axis. Where's your that's your x-intercept. Where's your y-intercept? That's where this one will cross the y-axis, so that's here. So y-intercept is 1. All right, now for this one, where is your x-intercept? Is where the graph will cross this x-axis, which is here and here. So you have two x-intercepts. They are 2 and a -2. Okay, and for the y-intercept, you have only one, which is a 4. And this one, where the graph, see, this one means touch. It touch and go, okay, touch and go. So the x-intercept is -1, and the y-intercept is +1. Okay, so that's the idea. All right, now there are 2 more things in the book, but I would not require, I'm not going to teach you how to use your graphic calculator, but if you do have one, I think it's a good time to read the instruction and to learn a little bit about how to use it. And I don't require that. However, I ask you to do this. Once we learn the x, y coordinate plane, I ask you to read the graph smart. Okay. For example, here's a x, here's a y, here's a 0, here's a 1, and here's 1. I just made these things up because that's all the information you need to set up this xy coordinate plane. All right, so I tell you this is time. It could be in minute, second, hours, whatever. And the y is what? Y is inches. All right. Okay, I want to show you something. I want to show you this graph. This graph tells you when time goes from 0, when the snow starts, and how many inches it get accumulated. So that's maybe in 1 hour. Okay, 1 hour, 2 hours, 3 hours, it goes like this. What can you tell from this graph? All right, I will use different colors. Here, I will use different colors to show the last one. Okay, so I should let all those points touch at the end. Okay, and I should let it go like that. What's the other color? Green. It's an interesting graph, isn't it? Because that shows these are 4 different colors. It shows the snowfall pattern in 4 different cities. Okay, green, blue, red, and yellow. So here is, let's say this is 10 hours. This is in hours. Okay, in hours. And this is in inches. So here's also 10. Now, there are 4 cities. I just call them a green city, blue city, yellow city, and a red city. In 10 hours of time, they get 10 inches of snow. But their graph, it showed that it's accumulated. Okay, accumulated snow. So they start from nothing at the beginning. They start snow at the same time, and by the time they're finished, they get a 10-10. So which is in 10 hours, they get a 10 inches of accumulated snow. What can you tell from this? Look at the red one. Okay, the red one, when time goes from here, 1, 2, 3, 4, that's evenly, right? That was time. So when time goes by, and that goes from like a 0.3 maybe, and then 0.8, so it goes like, goes up like pretty quick. So here was pretty flat. Flat means the accumulated snow grow slowly according to the time. So that is start slow, and becomes very heavy. It gets heavier and heavier. Make sense? And the other way is the green. See, the green at the beginning, in the first hour, it's already accumulated 3 inches of snow. That's pretty heavy. So get very heavy, and it gets lighter and lighter. Okay. What about the green one? The green one, from here to like a first 2.5 hours, it goes, it's very heavy at the same speed. At the same speed, because it's a line. At the same speed. But when time reaches to like 2.5 hours, do you see here was flat? Flat means the cumulated snowfall doesn't change, so it stopped. So flat means the snowfall stops, and then it start again, and then in the last 30 minutes it goes phew, like a dumping snow. So that's how you read the green, the blue. The yellow. The yellow is it comes down slowly and then it stopped. Even by the time like 7 hours, people there are pretty happy. They say, hey, it's already 7 hours past. We only get less than 2 inches of snow. But starting from here to here, there's like a 3-hour time window. The snowfall goes from here to here. Very heavy, super heavy, but they are pretty much at the steady speed. Make sense? That's what I call a graph smart. That's how you read the graph. The curve, if it goes flat, very flat means y no change. When x changes, there's no change in y. And it goes up slowly, that means when x increases, the y increases slowly. And then this one gets like a deep, like sharp, then that means the changing rate is really high. Make sense? So even for these 4 cities, their starting time and their ending time pretty much the same in the 10-hour window. Their accumulated snowfall was like 10 inches. However, if you see the pattern, you can see that very clearly from this picture. Okay, so that's what I mean, graph smart. I think that will be all for this session. Graph and graph utilities. Okay.